Okay, my babies. Today we're going to hit the slightly more complicated topic of multivalent metals and how that affects ionic nomenclature. All right? So, our EQ, what I want you to be able to do by the end of this video is you should be able to know, how do I name and write formulas for ionic compounds with multivalent metals. So, let's start with the word multivalent. Now, if you're paying attention, you see the word valence in there. And when we did our Mendeleev activity, we talked about valency, meaning the ratio in which it forms compounds. Okay? So, valent meaning ratio in which it forms compounds. Now, if you know anything about any prefixes, multi is probably one you're familiar with. Multi means many. So, you remember me telling you how we were going to skip the transition metals because they're weirdos and they do weird stuff and it's complicated, and we're going to skip the transition. We have arrived, ladies and gentlemen. We have arrived to our freaky weirdos in the transition metals and what they do. Multivalent means more than one possible charge. In other words, copper, sometimes it's +1, sometimes it's +2. Tin, sometimes +2, sometimes +4. Nickel, sometimes +1, sometimes +2, sometimes +3. Eek! Multivalent, more than one possible charge. So, how are we going to do this crisscross nonsense if there's more than one charge? Where are we going to get the charge from? We're going to tell you the charge. So, let's talk names with multivalent metals. You are going to do binary ones, just like you did before, non-binary ones, just like you did before, with one small addition. You add a Roman numeral. Roman Empire was a thing. There we go. You add a Roman numeral in parentheses between the metal and the anion. That Roman numeral is equal to the charge of the metal. Okay, Miss Crane, that's awesome, except if the metal has more than one charge, how are we supposed to know what the Roman numeral is? I'm getting there. First of all, let's make a list of all the Roman numerals. I is 1, II is 2, III is 3, IV is 4, V is 5. I think the only other one you'll need, VI, is 6. So those are your Roman numerals. Make sure you have them. You're going to need them. All right, so let's get to that question. Let's do an example, and I'll talk about how in the world, Miss Crane, am I supposed to know what Roman numeral to use for the charge of the metal if I don't know the charge of the metal? Okay, so let's say I gave you the formula CuCl2. Okay, and I asked you to give me the name of that. Well, this is binary, so we do the name of the metal, name of the nonmetal, chlorine, and then we're going to change the ending of the nonmetal to IDE. But copper is a multivalent metal. It is not group 1, group 2, aluminum, zinc, cadmium, or silver. So this has to have a Roman numeral in the middle. I have to tell you what the charge of copper is. How am I going to know that? Well, remember when we wrote the formulas, how we crisscrossed things? So what we're going to do is we're going to uncrisscross it. Does that make sense? So I'm going to take this 2 off the chlorine and call that the charge of the copper. Copper doesn't have a number on it, so we assume it's a 1, and we're going to put that on the chlorine. Super important. Check that this one is right. Okay, because remember we crisscross and reduce. So if it's been reduced, we might have to multiply it back up to where it's supposed to be. So chlorine has a -1 charge on our periodic table, and that's what we got here. So what's the charge on my copper? It's 2+. So this would be copper 2 chloride. Let's try one with a polyatomic ion in it. We have Fe2SO4 3. Okay. So we're going to name it just like we did before. That's iron. And then we name the polyatomic SO4. If I look at my polyatomic ions chart, SO4 is called sulfate. So now I'm going to uncross my crisscross. So I'm going to take the 3 from sulfate, put it on the iron. The 2 from iron, put it on the sulfate. Now we check, is sulfate really 2-? And if you look at your polyatomic ions chart, it certainly is. That means that iron's charge is 3+, so this is iron 3 sulfate. So let's try a little harder one. Okay, now here we have a polyatomic, and I didn't put it in parentheses because there are no numbers we added to it. I'm going to go ahead and put it in parentheses so we don't make a boo-boo. Okay, so if you have a polyatomic and it's not in parentheses, I would start by putting the polyatomic in parentheses so you don't make a boo-boo. All right, so we're going to name this, oops, that's so silly, Miss Crane. I meant to do copper and I did calcium. My bad, guys. Let's do CuSO4. Sorry about that. All right, so let's go ahead and name this. So we have copper, and then we have sulfate is the polyatomic ion. Okay. Now, we're going to uncross our crisscross. Well, we don't have a number out here, so we assume it's a 1. We don't have a number on the copper, so we assume this is a 1-. But wait just a minute now. Is SO4 really 1-? No, it's actually 2-. What are we going to do, Miss Crane? What are we going to do? We need to multiply both of these numbers to get the charge correct. So sulfate is supposed to be 2-, so I need to multiply this by 2. So that's going to change that to 2- and that to 2+. So this is really copper 2 sulfate. Okay, kinda tricky on these. This is probably the hardest type thing we're going to do, is with these stinking multivalents. All right, so now let's talk about writing the formula. Okay. This is going to be the same as before. So you're going to write the symbol, crisscross, exactly like you did before. But what you're crisscrossing, you just need to remember that the Roman numeral is the charge of the metal. Now, kids make a huge mistake here, and they think that the Roman numeral is telling you how many of that metal you have. It's not. Hashtag nope. Okay? That's not what it's there for. The Roman numeral is telling you the charge of the metal. So let's do a few examples of this. So we have manganese 3 sulfide. Okay, manganese is Mn. Sulfide, IDE, means we're talking about sulfur, the element. Sulfur is a group 16 element, so it's going to have a 2- charge. Manganese has a Roman numeral of 3, so it's going to have a 3+ charge. So we're going to take the 3 from manganese, that's the subscript for sulfur. We're going to take the 2 from sulfur, that's the subscripts for manganese. Simple, simple, simple. Okay? It's really easy. We told you the charge of manganese. Okay? That's what that Roman numeral is. Let's do one more, guys, and then we'll call it good. Let's try one that's got a polyatomic in it. Let's do chromium 2 carbonate. All right, so chromium is Cr. Carbonate, ATE, tells me it's a polyatomic. So I'm going to grab my polyatomic ions chart, and I'm going to find carbonate. And it is CO3, and it has a 2- charge. And that's a polyatomic, so we're going to put in parentheses. Chromium's charge, they just told me right here in the Roman numeral, chromium is 2+. So now when I crisscross this, the 2 from chromium goes to the outside of the parentheses for carbonate. 2 from carbonate goes to the chromium. Now can I reduce a 2 to 2? Yes, I can. So that's going to give me CrCO3. Done.